All right, there's a few people in now, so I might get started. Welcome everyone to Australian Builders Declare's 10th webinar on wood fibre insulation. My name is Hamish White. I'm one of the founding members of Builders Declare and director of Sanctum Homes, and I'll be your host for the evening. I'd like to begin by acknowledging the traditional owners of the land on which we meet today. I would like to pay my respects to elders past, present and emerging. Today's webinar, as I said, is on wood fibre insulation, and we have two guests joining us today. James Cornell from LifePanel. Give a bit of a wave, James.
Hello.
And we have Jesse Glascott from GLux Builders.
Howdy, guys.
James Cornell has been an industry expert on the topic of construction and sustainability for over 20 years. A licensed builder and a master carpenter, James became increasingly interested in sustainable construction and the use of materials in creating a better way to build and ultimately a better way to live. Moving to Australia in 2015, James shifted his focus from construction to education around sustainable building, and through his company LifePanels, he became the primary importer of wood fibre systems to Australia. His mission: to educate on the incredible benefits and demystify the science behind high-performance buildings. Jesse Glascott is a qualified carpenter with over 20 years' experience in domestic and commercial construction. Jesse started his own business at the ripe old age of 21 and became a registered builder at 24. Bit of an overachiever by the looks of things, Jess. In 2017, Jess became a certified Passive House Tradesman and redirected his entire business, GLux Builders, to focus on building low energy, high performance, passive houses. Jesse is also one of the 7 founding members of Builders Declare. Before we get started with today's webinar, I'd like to have a big shout out to today's webinar sponsor, and that is LifePanel. Thanks, James.
You're welcome.
Kick off today's event. I just want to say that the information you're about to receive is based on the experience of the presenters and may not relate to your situation. If you would like more specific advice, please get in touch with us via email, or you can get in touch with James at info@lifepanels.com. Today, as I said, we have 2 presenters and we're going to split it into 2 parts. The first part will be a presentation from James, talking about the benefits of wood fibre insulation. We're then going to throw over to Jess, who will walk us through a typical wall build-up for a mass timber wall assembly with rigid wood fibre insulation. We'll then have around 10 to 15 minutes at the end to answer any questions. Please place any questions that you may have in the question and answer box at the bottom of the screen and not in the chat box. So James, I'll throw over to you, and if you can get your presentation started, that'd be great.
Yeah, thanks Hamish. Thanks Jesse. Welcome everybody. Hope you have a good time tonight, and I look forward to the questions. I'll quickly show you the product and we'll review this later on. We do 2 main products, this rigid board, and we do a square edge profile, which Jesse will demonstrate, and also the tongue and the groove board. And we also do this 90mm infill bat as well. Just going to put it down there so it doesn't fall off onto my head. Okay, so I'll share my screen and we'll go through some details of building physics. Oh. Okay, here we go. All right, so I want to start with the big picture. So what I want you to think about tonight is it black and white? I don't know about you guys, but I find a lot of people at the moment, because of social media, we've got this expectancy that things are super quick, super fast to happen, and that there's this sort of black and white thought process behind a lot of construction and detailing and materials. And but often, as you can see from the screen, I just want to encourage is that it's just quite grey, and you've got to really look hard to see the detail and kind of work out what's best to do. So we've got innovation and connection. Now, do we view those in isolation, or do we view them where we've got to look at why we've invented something in the first place? And an example of that is this bolt-on methodology, which creates this kind of black and white scenario where we go, okay, we've got a problem with damp and mold, so we just need a dehumidifier, happy days. And that's good to some degree, but I just want to encourage tonight as we look through this and talk about these materials, they're actually looking at, before the material choice, looking at the big picture of moisture behavior and heat and cold energy behavior. And then when we start to understand a little bit of that, we can choose materials that work well and help with those dynamics rather than hinder those dynamics. So innovation and connection, are they viewed in isolation, or what does that even mean? Innovation minus connection, stupidity. Hopefully that's getting a laugh, because I can't hear anything. It usually gets a laugh. So what we've got to do is have innovation plus connection together, and then we're going to get better and balanced outcomes. And an example that I want to talk through is from this movie. It's an Aboriginal movie called 10 Canoes. And in the movie, they arrive at a body of water, the mangroves, and they talk about needing to get onto the water and get across the water, and do whatever they need to do. Now, from a Western perspective, quite often we would arrive at this scenario, look up and down the shoreline. Okay, we've got to get across. So there's a couple of trees here. There's some twine there. We'll use that for rope. We'll just chop these trees down. We'll make a raft. Off we go. Now, in the movie, what they do is they turn around, and the phrase they use is, the best timber for a canoe is nowhere near water. I'll say that again because it's pretty good. The best timber for a canoe is nowhere near water. And they backtrack into the bush, and it shows you the process they go through with the tree to remove the bark, dry the bark, shape the bark, wet the bark, and the whole process. And then they end up with this super efficient machine. It's the best tool for the job. It's going to last the longest, perform the best, and aid their task in a better way than if they'd not done that. And so for me, that encourages me to just say, you know, do we want to stand on the shoreline and then possibly damage the delicate ecosystem of the mangroves because we're failing to recognize that the innovation that we're about to create using the immediate resource could actually then create other problems, whereas thinking a little bit differently about situations is going to help us get a better system and not damage the delicate ecostructure of the mangroves around us. So obviously that's an analogy to say we can't just have this black and white approach to building. We've got to consider the whole process and the different materials that we would choose. Most of you may be aware of Dr. Wolfgang Feist, who was the founding father, I suppose, of Passive House movement. And this isn't a quote, but this is the ethos of what Passive House is about. It's a fabric first approach, the building envelope, and we've got to learn to be better at building. The reason why I say Passive House fabric is there's two elements missing off this page, which would be the windows and the doors and the heat recovery ventilation system. But the reason why we're talking about Passive House fabric is that we're looking at the raw material that we're going to build the envelope from and how they are affected by and change the behavior of moisture, heat and cold. Bit of an intro for Passive House. I'm sure most of you are quite familiar with these terminologies at the moment. Passive House generally looks at those design components. And like I say, there you see the ventilation, the windows and doors. And then it uses the PHPP software to assess the climate zone, the orientation of the building, shading, all of those aspects to see if the building will actually perform. But what it doesn't do, and this is where the education and the experience come in is that it won't assess the moisture behaviour within that proposed build-up. So you can actually get passive houses that use materials which may not be the best material for that location. And so the way to test that out is to use a software called Woodfibre or a hydrothermal analysis software, which will basically look at the temperature, relative humidity and the moisture content. And then it will show you, it's a very simplified version, but in that graph there, you can see winter, you've got high levels of moisture, and then in the summer you get low levels. Now that varies climate zone to climate zone. So it's really important to speak to people and understand the design. And various materials can make the moisture level worse depending on the different aspects of it. So one thing I want to encourage tonight is don't just take my word for any of this. It's always great to do your own research and get the material that you're interested in using, get their data sheet from the supplier. And these 4 main criteria should always be on that data sheet to help you understand what it is you're buying and how it performs. So we just got here a very simple explanation of wood fibre insulation versus a synthetic insulation, and the density, thermal conductivity, the specific heat capacity, and the vapor diffusion resistance. And obviously you can see the higher the better, the lower the better, and so on. And then the decrement delay is how long it takes the sun's heat to pass through from one side to the next. So you obviously want that to be as high as possible to help with that internal comfort. So these big 3, the next slides are going to be for each one of those headers in thermal performance, moisture control, and overheating control. So we're not going to spend too much time on these, but just to give you a general feel, and then we can drill into some detail later. Low thermal bridging. Think of it as dropping a tea cozy around your house and getting that continuous insulation around, which basically reduces the thermal bridges in the property and enables a higher performance during summer and winter. Air tightness, this is quite a familiar one over the other aspects of building physics, particularly with vapor permeable membranes. And the basic idea of it is that we're wanting to reduce the air leakage, which is good for the building fabric, reduces the risk of molds and condensations within that fabric, but it also helps balance out the internal temperatures to a nice stable temperature around 20 to 25 degrees is the aim. And yeah, that's a good one to do. Breathability, or the preferred term is actually vapor permeability. But I feel like people mentally can kind of grasp breathability a little bit more. And what I'm going to show you when we stop sharing the screen is this coffee pot that I've got with me. And we'll go through that in a moment. But yeah, we need to use materials that are highly vapor permeable. And if you remember in those 4 criteria, we see that wood fibre has got high vapor permeability versus the synthetics, which often don't have the vapor permeability. So it can cause problems with damp in the wall space. Relative humidity. This is probably one of the most complex of the building physics. But what we're aiming to do is get to around between 40 to 60% relative humidity. And then the internal temperatures to be between 20 to 25. I actually prefer it a bit warmer, around 26, 27. But that's when you're going to get an optimum internal temperature, which is also good air quality and comfortable living. Thermal mass, this is a good one for discussion. But essentially what thermal mass is doing is working with that specific heat capacity of a material based on the densities that to buffer the heat, absorb the heat, and help regulate the temperature internally. And this has to work well as part of the design. And again, back to the black and white aspect, it isn't black and white. It's not a, one rule for this, one rule for that. It's complex and requires the knowledge of the certified passive house designers that you may use, or the architect you may use, or the builders that you may use, and the material suppliers that you may use. And then decrement delay, we touched on this earlier, slowing down how much heat is getting into the building is crucial to do. So we need to think about that in the construction of it. Now, this is just a brief overview. Thermal performance, we know why we've looked at that. We're going to insulate the buildings continuously, but what can happen with that is the more we insulate the buildings, if we don't understand moisture behaviour, what we can do inadvertently is then create way more moisture internally, which will actually increase the risk of damp and mould. So we need to then consider the other aspects, the relative humidity, the air tightness and the ventilation, to make sure we're managing that moisture efficiently. And then the moisture control in the middle there is that materials need to be good at releasing moisture so that the vapour can pass through from the inside of the building to the outside of the building without getting trapped. And that's one of the most crucial things that often gets misunderstood. And then the heat, overheating control is important. And this is just a fun little experiment that we do with a heat lamp. Just shows 4 generic materials and just how they perform to heat. And as you would expect, tin, which is highly conductive, changes by 48 degrees on the face. The top line is on the front of the material and the bottom section is on the back of the material. So you can see within 5 minutes, the heat is already on the back side of that material. A polyester, a similar thing, that's absorbed a lot of heat by that time, so it's starting to radiate through. And so that's generally the Australian methodology at the moment, which has worked for a long time, but now people are now increasing that insulation. We're now seeing problems with the overheating and with the mold and the damp. So it's now changing that education around good wall details, good roof details. The foam, this is a great one because the foam performs really well. As you can see, only a 3.2 degree difference on the back. But then you go back to the 4 criteria and what is the vapor permeability of that material, and it's practically 0. So therefore you can see a conflict of, it's a great insulator, but it's not vapor permeable, so that can then lead to issues if not detailed correctly. And then the wood fibre, as you'd expect, there no change at all with the wood fibre, but that's only 5 minutes, so that will change, and that's why it's important to consider the design. Okay, just in summary, we've got the most cost-effective way to use as little energy as possible is this fabric first approach, because getting that right will reduce the load that we need and the electricity we need to run the HRV systems, because they won't need to work as hard if we don't do the fabric first approach. Then we need to slow the heat loss in the winter. So we can do that with wrapping the building like a tea cozy, low conductive materials and the air tightness system. And then we're slowing the heat gain in the summer by using materials with, that should primarily say, high specific heat capacity and low conductivity. And to ensure that there are no intended consequences as a direct result of high thermal performance, we need to use vapor permeable materials. And wood fibre is good for doing that. Now, the other aspect to consider would be the ecological and the sustainability aspects of that, the embodied energy within the material. How is it made? What's it made from? Does it give back? What can you do with it at the end of its life? All those things. So that's pretty much it. Hopefully within time scale. I've got 14 minutes on my clock, so I was planning for 15. But if you don't mind, just take a quick moment to grab your phones and just scan that QR code, and it takes you to our Google review page. So as a small business, it really helps our opportunities if you can leave reviews, and then also some feedback on if you find this kind of information helpful, if you'd like to know more. It really helps to make the presentations better for the future. So please just take a moment to do that, and then hopefully we'll get some great questions, and we've got an epic demonstration from Jesse. So we'll move on to that, and I'll just stop sharing the screen. Hopefully people have grabbed that code, and I'll show you the coffee pot. So jump back. Here we go. So hopefully you can see all that condensation on the inside. Now that's what we don't want to happen inside our walls. So we've got to think about the vapor permeability of the materials and the design that we've chosen. So that's it.
Thanks, James.
Thanks.
So probably just one thing I just will touch on just before we go on to Jesse, that James did talk a lot about Passive House then. And I just kind of want to jump in quickly and say that, you know, this particular webinar is not just for Passive House, but, you know, wood fibre insulation can be used in, I guess, any construction. Is that right, James?
Yeah, that's a great point, actually. So one of the big things that people get a bit alarmed about is, oh, but we don't want to go Passive House. We don't want to live in a sealed box. And that's fine. And what's brilliant about the knowledge of Passive House is for people who are skilled and trained in it, you're able to just take elements and say, right, well, we don't have to go to that full extreme. And Passive House has got just a basic level of just a high performance. It's also got an aspect of called Enefit, which is to do with the retrofit of existing housing stock. So it's quite diverse, and I think that's something that would be keen to educate people on, that this new phrase, Passive House, shouldn't be this scary thing that only a few can access. It's actually just some basic principles like we've looked at with the physics. And if you just apply a few of those, you're able to get a really high performance house that's healthy to live in without being too scary, hopefully.
Yeah, awesome. I mean, if anyone knows me, I mean, I'm a massive advocate for Passive House, but also recognise that there are, you know, a lot of other ways to achieve a comfortable, low energy, healthy home. So what we might do now is throw over to Jess, who's going to walk us through a wall builder. So I'll let you explain what you're doing there, Jess. And what I'm going to do is leave James's video going too, so Jess and James can go back and forth and answer any questions or further explain what Jess is actually doing while he's doing it. So I'll let you guys carry on.
Sweet. All right. Thanks, Hayne. Thanks, James. You see me all right here, James? See what's going on?
Yeah, looking good.
Sweet. All righty. Thanks, guys. Today I'm doing a wall build up from a mass timber structure with some rigid wood fibre. So this piece here, we've got, it's like a 5-ply CLT. So generally the CLT is always in odd numbers when they laminate it. 5-ply, most of the time you get air tightness through it. 3, they don't guarantee. So this piece here is airtight, but we always still recommend doing a air tightness layer because obviously we've got a surface, internal surface CLT in this wall build up. We can't have any internal air tightness membrane, so you put it on the back of the panel. And now we generally, you want to, once you get your panels up, you want to make your building waterproof anyway. So it's always good to put this in, even if it's a 5-ply, you'll still put it on anyway. Now you can use a product called Adhero as well, which has got the adhesive back. This one here isn't. This is just your standard extruder. The Adhero is awesome to use. Bit trickier. It's got a bit of art to applying it. I personally haven't used the Adhero myself, but a few of my guys say once you get the knack of it, it's awesome. But to try and do like a super long run on a wall that's got scaffold in front of you and that, it's probably a bit too complicated. You're just better off sticking to this product, stapling it and taping it. So yeah, this one here, we've just gone for the standard extruder stapled on. And the next element to this wall build up is the insulation to the bottom of the wall. And I know, James, if you want to explain why we do like a closed cell insulation instead of running a wood fibre product down to the ground.
Yeah, so the context of that specific detail is anywhere where the walls will meet the ground or a deck that comes into the building that's exposed to the weather, you just need to protect that first 300 millimeters where the rain's going to hit the ground, bounce off the ground and onto the wall. But you've also got the rain running down the wall, so you just get a high concentration of liquid moisture in that section. So just the standard detail in Europe and for the wood fibre in particular is they just want to protect it from getting smashed with, you know, say 2 weeks of rain. Now, It's important for the vapor permeability that it will dry out very quickly. which is important, but you just want to protect it. So standard 300 millimeters where the natural ground or a deck meets your wall, like you've got there, the little block. Yeah.
Cool. Well, the wood fibre we're using today is 180 mil thick. So we've actually just got 3 layers of 60 just to pretty much get the same thickness just for the wall build up to make it easier. Now screws, I'm going to use the same screw to screw on the closed cell as what we would use for the wood fibre. So as you can see here, we've got a thermally broken washer head. James, do you want to talk about how important these are and why you recommend them on all builds?
I've got the baby version of it here. This one's for the 60 millimeter board, and you'll see Jesse about to screw that in. This is for the 60 mil, which would go into the board, and you get a 40 mil embedment into the frame. But what's important about this particular fixing over, say, a standard fixing is that the screw, as you can see, is buried quite deep inside the washer head. The screw itself is a low conductive metal, and then we've got this polystyrene bullet which pushes inside like that, and that actually creates the thermally broken fixing, so you get a low thermal bridge. And the conductivity of a regular screw would be somewhere between 0.9 to maybe 1 watts per meter Kelvin, which that's the technical geeky bit, whereas this screw and the screw that Jesse's using, and also the washer to fix to wood fibre to masonry, is 0.002 watts per meter Kelvin of conductivity, which is excellent. So that's why you do those washers.
Cool, thanks, mate. So that's all screwed off. So yeah, time to put some wood fibre on.
You got a new drill there, Jesse. It was very quiet.
Yeah, I thought I'd better mute it for you. Now I'm about to get noisy, so I've just got a piece. You should be able to see that okay. All right, so I've just got a slab up here. You remember the size of these, James? You probably know off the top of your head.
1.38 by 600.
Yep, correct. All right, what I'll do is I'll just trim off maybe 300 mil. Safety first, eh?
Yeah.
I'm just going to use just a typical battery saw. All right. Now, obviously, it's not going to cut through the whole board. So we'll flip it over, cut it through. Now you can get like a Fez tool, track saw, or even the chainsaw one. Isn't that right, James? Yeah, cut through it in one go, but I haven't got that set up here tonight. So
yeah, for the most part, you can just use regular site tools, track saws, jigsaws, bread knife. Yeah, you can even plane it if you need to. That's always fun.
Alrighty, so to get through, I guess we just use a basic small recipro to sort of finish it off. Alrighty, there you have it. So as you can tell, you can get some rough edges. If you really want to, you can run your buzzer along that too. So just Just put my safety on. So that's it. You get a pretty much a nice clean finish.
Nice. It's worth noting at this point as well, Jess, when all the offcuts are on the ground there, sometimes it's not too much of a problem on CLT, but if you miss a stud with the screw, for example, and you've got a hole, you can just grab a handful and then stuff it in the hole. And if you're going to render the boards, it's fine to do that. And also if you're going to use the membrane and then clad it, it's also fine. So if little bits and pieces break off, it's okay. And actually, I'll just say as well, you're using the square edge there. And the reason why you're using the square edge over the tongue and groove is because you're going onto a solid substrate like the CLT or mass timber. You'd only use the square edge in that application. Yeah.
Yeah. So the tongue and groove you do over your stud because you'll be joining off stud, yeah?
Yeah, that's right. Yeah.
Yeah. And I guess it's probably a cheaper option, is it, to buy a rigid board square than tongue and groove option?
Yeah. Yeah.
So here's one I prepared earlier.
I was going to say, it looks like you measured that.
Didn't want to be cutting all night in front of you guys, so.
Yeah, great. Perfect.
All right. So now we back to the thermally broken screws once again. Now, James, I don't know if you want to talk about the spacings and centers for these screws for different applications. I mean, this one here, I'm just going to be doing a typical lightweight cladding system.
Yeah.
But I guess maybe if you're doing a render system, you'd have different amount of screws.
Yeah. So if you're going to render it, we generally say 6 fixings per square meter. And you'd stagger the joints as well, like brick bond. Just as a general rule of thumb, it's always good practice to do that. So yeah, 6 fixings square meter if you're going to render the boards. Where in the context of a job like the one Jesse's used these on, you only need a couple of fixings to just hold the boards in place, because what will happen is, I think you'll see in a moment, Jesse will put a membrane over that, the vapor permeable membrane, and then you get the vertical batten system, which will create the vented facade, and the battens will screw through the batten, through the wood fibre and into the substrate. So that will actually hold the board into position.
All right. And now that's screwed off, we just put the little closed cell and we've broken caps in.
Yeah, it's good to get into the habit of that as you go, because you like anything in construction, if you go, oh, we'll do that later, inevitably you don't. So just from a practical point of view, keep them in your tool bag and just pop them in. It's quite satisfying, Jess, hey?
Yeah. Probably not when you got to do 1,000 of them.
Yeah.
All right, so that's probably enough fixings for this for now. All right. Next in line, we've got our next layer of extra weather tightness membrane. So usually you've always got another set of hands to give you, to fix this on. So what I'm going to do is show you a stapler. Generally, we use a typical battery stapler like this for all our wrap applications. Now these, because of wood fibre, even though it's dense, it's still not going to really hold. Really. So I'm just going to show you how it's probably going to collapse here.
Yeah, exactly.
So we probably just, you recommend, James, just whacking a couple of these in just to get you going?
Just put 1 or 2 in just to help it stay taut. And then obviously when you get your battens on, and like you say, you usually have someone else to help you at this point.
Yeah.
So yeah, you can do that.
That'll probably do for now, just to hold it up.
Yeah.
Get stuck into these buttons. So for this particular build up, I was just going to put a sheet of WeatherTex cladding. So I'm just going for a vertical batten system. So not needing any counter battens or horizontals for this. Now the screws we've got are double threaded.
They're the worst one.
So I don't know, James, if you want to get behind the science of why we're using something like this.
Yeah. So there's a few different brands that you can get, but the primary reason you'd use one of those is it's double threaded. So and that basically means you've got a reverse thread and the regular thread. So it's actually engineered to pin the batten through into the frame, but also stop it from vibrating when you get wind loading. Essentially what could happen is the screw could wobble loose. So the reverse thread is engineered to counter that. And then again, the stainless steel nature of that screw means that it's got very, very low thermal conductivity, which is what you need as part of the high performance solution. So they're pretty monstrous screws, but I mean, the tools are amazing how that they've got these days with the torques of the drills, and pretty good.
You usually have to like back it out a bit and back it back in because of that double thread at the end. It tends to want to pull that batten off a bit.
Yeah, okay, yeah.
But it's better than, if you're using just a standard screw like this, that's going to tend to probably pull your batten in a bit too much into the wood fibre and compress it slightly. So at least with a double thread, that stops that from happening. These are pretty hardcore. Generally, you don't have to pre-drill. So that one was pre-drilled already, but we'll do one without.
Okay, cool. It's worth just throwing in, Jesse, at this point to just say about the vertical battens first and why you wouldn't put horizontal batten in first.
Yeah, sure. Yeah. I mean, ventilation cavity behind any cladding is important. Yeah, for this particular one, we're going to have a 35mm ventilation cavity. So it's pretty much like a range screen, really. So if you were to put your horizontal batten across first, especially on a wood fibre, you've got the rigid board behind with your batten here. So for starters, you're going to block this ventilation path, which is important. And any moisture that gets built up behind this cladding isn't going to be able to escape properly behind the batten. So if you were to do a vertical cladding system, you would have these vertical counter battens, and then you'd have a horizontal across like this to fix your cladding to. So,
yeah, nice.
Yeah, for this particular application, vertical spine.
Yeah, great. And I'll just add to that as well that in the context of bushfire zones, you can still use the wood fibre, and because any bushfire codes will say specific membranes that you have to use with a flammability index of less than 5, which those particular membranes have got. And also the proprietary cladding, whether it be FC sheet, Core 10, Colorbond, brick, WeatherTex, whatever you want to use as your finish, would also, in their stipulation, would say whether they're compliant to the bushfire rating. And therefore, that system that Jesse's building at the moment would comply. And you'd also have a stainless steel mesh of about 2 millimeters, no bigger than 2 millimeter apertures, which would protect it from ember attack. So it gets quite technical, but it's quite a safe way to build. That moisture is not going to get trapped in there, and the moisture content isn't going to get too high in any of the timber elements or the framing to cause any problems.
I'm just going to take this screw out now. Just to crease the wrap a bit, and then we'll just patch that with some tape.
Yeah, it's a good one.
Hey, James, just while Jesse's doing that, maybe just have a quick chat about some of your like bulk fill installation while Jesse's. Yeah.
So we've got, I think I've got a small sample here. So 90 mil thick. You can see how solid it is. So the idea of this is that it won't sag under its own weight, because with some synthetic insulations, they'll actually sag under their own weight. So particularly when you put them in a wall, see that, if I put that in there, typically they can sag a little bit, and then you get an airspace. So obviously it becomes less efficient. So this is structurally stable, and partly because of the density of that, it is very high, so it holds its structure. And
so if we were to put a thermal camera on a frame with wood fibre insulation, it would see less old spots in there than we would with some other.
Yeah, you've seen the ones around where it shows all the and these are pre-sized to go with. This is a 450 centre frame, so they would fit inside there. And the one, you can't see it, but the one on my left is a 600 centre frame, so pre-sized, and they just tuck in real easy.
I'll let Jess get back to doing what he's doing.
Yeah, final finish, really done.
Nothing too exciting now. We'll just put the cladding on if I've got nails in my gun.
Good.
Hang on, no nails, guys. All right, well, I guess that's pretty much typical wall build up for mass timber with rigid wood fibre. So
looks good.
Cool.
Nice work.
Thanks for that, Jess. Just a quick one. I mean, that's quite a big wall build up that you've got there, Jess. What would be the R value in that whole wall assembly there?
Yeah, that's a good question. I guess the mass timber is 160. So you're probably looking at around 1.5 there. The 180 rigid, I think James is around 4.5. Is that right?
I'm gonna look for the thing and tell you.
Yeah, I'm pretty sure. So you've got you got around that R6 for that wall build up, and I can tell you the width. It's pretty. It's pretty thick. We're close to 400 here. So.
And just on that decrement delay thing we looked at, I think with the decrement delay on that 180 mil thick, you get like 10.5 hours just on its own of heat absorption. And so it really slows down and protects the building from summertime overheating.
Yes.
Yeah, so that wall assembly that you've got there is a super high performing, airtight, vapor permeable wall assembly.
It is. It's pretty hardcore, that one. Yeah.
So if you guys don't have anything else to add, we've got a few questions here, and if anyone else listening has any other questions, by all means pop them in the question and answer. James, I know that you import a lot of your product from overseas. There's a question here. Is there any sign of local manufacturing happening?
Good question. I can't go too much into detail, but yes, very serious conversations are taking place, and I'm doing a lot of hard work and research to look to manufacture in Australia. So yeah, definitely.
Awesome. Yeah, that'd be great to, I think as high performance home gain more popularity and become in high demand, I think we're going to see a lot of these products that we are importing from overseas hopefully become manufactured locally.
Yeah.
There's a question here from Ben Mitchell, and it's, I don't know how you're going to answer this one, but what's the comparative cost and benefit of wood fibre versus traditional bats?
Great question, Ben. So the first thing is to go back to those 4 criteria, and the particular one in most contexts is the density. So generic insulations and synthetics have only got a density of somewhere between 10 or 20. And if you get the sound screen, I believe they're 20 at 90 mil. The density of this 90 mil is 60 kilograms, so 3 times denser. And the density of the rigid panel is 145 to 180 kilograms. So really, you have to look for the comparative density to ensure you get the same performance. And that's why it's a little bit deeper than just R value, because you can get the insulation that's got the density of 20 has the same R value as this, but an entirely different performance criteria. So check the data sheets, but to get the same density in a synthetic is actually more expensive. But as a swap from traditional insulation that you would have in a standard build to go to the wood fibre, it can cost somewhere between an extra 1% to 2% more expensive just for this one. It jumps in price, obviously, as a system, but I've got documentation which can be happy if anyone to contact me and we can review that.
Yeah, I'll get your, I'll let everyone know your details at the end if they want to know any more about the products that you offer too, James. So hopefully people will get in contact with you directly. So there's a question here. Where do you get the thermally broken washer head screws from?
From me.
Again, we'll hand out your details at the end, James.
Yeah.
The double threaded screws for the battens. Rotherblast.
Yeah, Rotherblast will work.
Bit of advertising there for Worth. There you go.
Also, there's an Australian company called Screws, and they do a panhead double threaded screw, but I'm not sure of the thermal conductivity of those screws. But yeah, that's another company, Screws, they're called.
Jess, thank you for being so good with your PPE, but there is a question here. Should we use a dust mask when cutting life panel?
Yeah, like any material, it's always PPE, just recommended. Wear a mask. So it's not itchy, so you won't feel itchy from using it. But obviously, like any fine dust, it's gonna, if it gets into your respiratory system, you're gonna notice a slight change in how you breathe. So yeah, always generally recommend wearing a mask. If you don't have a mask, you're outdoors, but you've got all the Festool vacuums and whatnot, you can just hook those up to the machine and keep sucking up the dust. But yeah.
Jess, you can thank Jeremy for throwing you under the bus there, mate.
You can tell Jeremy I've been wearing a mask enough this year. I just wanted to break it, right?
Now, so this is an interesting question, and I was thinking the same thing. So, is the first membrane layer that you apply directly to the CLT or mass timber required, or is it just discretionary? I understand that you'd need to do the external one, but do you need to do the one immediately onto the CLT?
Well, it depends if you're going for air tightness. Really, I mean. Generally, you'd want to put one on and get your building envelope wrapped anyway. That's the way I see it.
So you're saying, Jess, in this build-up that if this was a passive house or we were shooting for a certain level of air tightness, that's where we'd put our air tightness membrane?
Yes. Yeah.
So my response to that is again, this is where it comes down to not the black and white. So in some climate zones, that specific build-up will be specific for that site, which will be suggested by the PHPP, confirmed by the Woofy analysis. But then in other climate zones, it may be that you put it on the inside. But then if you've got the context where you need to see the inside because it's CLT, it may be only required on the outside of the wood fibre, or you can use line renders. So it does vary site to site, but that's why it's good to speak to professionals who can help detail all of that.
Yeah, I think generally, typically, if you're using the flexi and the combi combination, you'd probably, if you're going for passive house, you'd probably have like some sort of Intello system inside on the face of the studs, wouldn't you, James? So.
Yeah.
Another question here. What sheet size does the bulk fill come in?
Oh yeah, I think we touched on this briefly, but the bulk infill comes in 415 millimeters to fit in between the 450 centre framing and 575 to fit between 600 centre framing. And they are 1.22 meters tall, I think.
Awesome. Now, this next question is actually a question that I think I'd asked you a few weeks ago, James, for a project that we've got coming up. This is from Brian. Can this product be applied to a double brick building? And if so, what would the application be? Are there any moisture dew point concerns?
Great question, Brian. So again, that would be site specific and context. So we'd need to know where your site is, the orientation of the building, and then look at the climate data and probably a Woofy analysis. But in theory, the wood fibre rigid board can be retrofitted internally, can be retrofitted externally, and it can be rendered with a lime render or clad. So obviously there's negatives and positives for that. If you're going to do it internally, you're losing wall space. If you do it externally, you've got to extend all of your pipe works and whatever else, window reveals. So retrofits are usually more expensive. The dew point concerns would be primarily with a brick on the inside, so it would mostly be beneficial to do it on the outside of the brick. But if you want to keep the brick, then it really is context specific. So more detailed analysis of that particular project.
I think
it says R value there. I'm just sorry to interrupt you.
No, it's all right.
R value is the product. So again, it's not just about the R value. So just bear that in mind. Back to those 4 criteria we looked at. But the R value of the 60 mil board on its own is R1.45. And the R value of the 90 mil bulk infill is R2.55. And because the recommended system, if you use them as a combined system, you will get R4.05 from the insulation alone.
This is a really great question, actually. In fact, 2 people have asked similar questions. So can you let us know what the life panels are made from? So this is a 2 or 3 part question. So if we can just answer that question first.
So it's made from primarily spruce timber, between 82 to 90% spruce, which is a pine, radiata pine timber. And it's made in Europe from basically recycled plantation, they call it, or rotation crop. So, huge areas where they start with mini saplings all the way through to mature age trees. And then the mature age ones get felled and used for house framing and other timber components, and all the waste and the offcut gets turned into the wood fibre material. So in its production, it is 100% sustainable and renewable. It's also carbon negative. It's for every 1 ton of material made, it locks up 1.2 tons of carbon. And then the next question, which naturally leads on from that, is, well, shipping it to Australia is terrible. But actually, the sheer volume that these huge cargo ships bring is actually less carbon or comparative carbon to, say, just one semi-trailer driving from Brisbane to Sydney. So the actual footprint is deemed as less. But then we've got 80% that's fairly good, and we know the 20% that's not great, and that's why we're looking towards manufacturing Australia to make it even better. So
awesome. So what you're really saying is that more people need to start using Woodfibre, James, so we can start manufacturing here.
Yeah.
Awesome. Can Woodfibre insulation be used in any class of building?
No. So particular, I can't remember exactly off the top of my head. Most types of building, most common types of building, yes. But specific ones like hospital corridor hallways and I don't know, certain types of treatment plants, things like that, then no. But yeah, as a general, most residential, commercial and bushfire regions, yes.
And probably leading on from that, how are you finding building surveyors' reactions to the Woodfibre externally?
For the most part, we are, I believe, the only importer in Australia who's paid to have the Woodfibre fire tested to Australian standard, and those documents are on our website. And then we're also part of a NCC approved system, again, which is something that I and Life Panels have paid to be part of.
So do you have a performance solution which you can provide?
Yeah.
The builders, yeah, awesome. Is there another option for the poly plug?
Is what, to not use the poly plug or to not use that screw?
Well, maybe maybe the implications around not using the screw, because I guess that whole thing is around reducing the thermal bridges.
Yeah. So I mean, I suppose if the question's from a sort of an ecological point of view of a polystyrene bullet, obviously polystyrene is not great. So maybe there is another option, but in terms of the performance, it's going to be encased in the building. So the likelihood of any ecological damage is reduced, but it is crucial to seal that screw, because you don't want heat or cold energy traveling through the screw and conducting through onto the inside of the building. So yeah.
Two more questions and then we'll probably wrap it up. Can you render straight onto the Woodfibre, or do you need to mesh first? So what's the system, or what's the process that we go through for the rendering of the Woodfibre?
Yeah, you can render the boards. If you have a bushfire area, you can't render the boards, but no bushfire area, you can render, and there's a render data sheet on our website. So currently there is no system warranty offered by Rockcoat is the particular company, but active trial, and it says it on the bottom of the render sheet, there's been an active trial for over 2.5 years, and so far high performance, no cracks. So we're in conversation, and also with 2 other line render suppliers, to offer a full system warranty with the line render. But it's common to render it. It's done in Europe, peeps. And the line render is crucial with the mesh, because it allows stress points, particularly around windows and doors. But yeah, ask me for details on that.
Yeah, awesome. Well, we'll be doing that on one of our upcoming projects too, so we can all also have a bit of a test case as well. Now, just the last question, how's it made? Does it have any fire retardants or chemical treatments within the fibre?
Yes, it does. But like most products, it's all got very strict codes to adhere to. So the Woodfibre is deemed as non-toxic, non-off-gassing, so no VOC, and the chemical components are less than 4% of the makeup. And the fire retardants are obviously to help partly with the fire, the fire protection of the board and the material.
Awesome. Well, I'm going to wrap it up now. Thanks, James and Jesse. It was a really informative presentation. And another big thanks to Life Panel for sponsoring this webinar. If you would like to know more about any of the products that Life Panel or James offers, get in contact with him at info@lifepanels.com or www.lifepanels.com. So there's no AU, is that correct?
Right, just .com, yeah.
.com, cool. Now, Our next webinar will be presented by one of the other founding members, Jesse Spencer, and it will be what makes and what breaks a high performance home, and that will be part 2. Now, part 1 is actually available on our YouTube channel, so don't forget to jump on there and subscribe to the YouTube channel. We've also started a Facebook group too, and I'll just double check to see whether or not Jesse had, no, not Jesse, Simon. Jeremy, that's it. No, he hasn't said what it's called, but anyway, I'll send it out in an email after tomorrow when I send out the live recording for this. But if you want to get in contact with us at Builders Declare, it's info@buildersdeclare.com. Don't forget to follow us on Instagram, and definitely check out our Facebook page and that the Facebook group. Thanks again, Jesse and James, and thanks everyone for coming.
Yeah, thank you guys. Great.
James.
Good night.
Thanks.
Well done, Jesse.
See you guys.